All right. In 6.2, we're talking about properties of parallelograms. Now, the first thing we need to know is, like we just said, a parallelogram is a quadrilateral. A parallelogram is a quadrilateral. That means that it has four sides. Parallelograms have four sides. And the reason we call it a parallelogram, I'm really hoping that that word parallel in that name rings out to you. Okay, it's called a parallelogram because both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. Now, we cannot say that all four sides are parallel, because all four sides are not parallel. Meaning, I cannot say that this side is parallel to that side. That's obviously not true. Okay? Opposite sides in a parallelogram are parallel. That part is true 100% of the time. Okay? So, we're going to go through and talk about some of our angles here. So, first off, before we get into our theorems about parallelograms, there is an abbreviation for parallelogram. Kind of like when triangles. When we talked about a triangle, I said, hey, we've got triangle ABC. Right? Well, parallelograms have its own symbol. Anytime you see that symbol, literally looks like a little parallelogram. Okay? Anytime you see that symbol, they're talking about a parallelogram. They are not talking about a general quadrilateral. They are talking specifically about parallelograms. Okay, so please be careful about that. They're talking specifically about parallelograms when they use that symbol. And so then you could say that you're talking about parallelogram ABCD. Okay? All right. So, let's take a look here. Theorem 6-3. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So, right away, we know, hey, we have a parallelogram ABCD. I know it's a parallelogram because the opposite sides are marked parallel, and it's a quadrilateral. Because I know that, I can then say that my opposite sides are parallel. Congruent. Opposite sides are then congruent. Because it's a parallelogram, I can say that the opposite sides are going to be congruent. Okay, let's talk quickly and why. Why can I say that? Well, if I just look at this shape, okay, I'm going to zoom way in here so I can write on it. You don't need to write this down, but please pay attention to what I'm telling you. Okay, why do we know that if we have a parallelogram, then we must have congruent opposite sides? Well, it comes in, if I look at, let's say, this diagonal. That's a horribly drawn diagonal. Please imagine that it's straight. Okay? So first off, I know that in this diagonal here, this diagonal is being drawn, I've got that side is congruent to itself, right? I know that this angle is congruent to that angle because they're alternate interior angles. They are alternate interior angles, so they must be congruent because they have parallel lines. This angle is congruent to this angle, again, because they're alternate interior angles, because of the other set of parallel lines. You guys with me on that? That means that this triangle over here and this triangle over here must be congruent to each other by angle side angle. Remember that angle side angle stuff way back when? Yeah. And so therefore, if they're congruent triangles, that means that their sides, the opposite sides here, are going to be congruent because those are corresponding parts of my two congruent triangles. This side here and this side over there are going to be congruent because they're corresponding parts of my two congruent triangles. Okay? All that stuff we did in first semester about congruent triangles applies here. This is where we get our properties for parallelograms, is by looking at our properties of congruent triangles. Okay? So if you know you have a parallelogram, then you know that the opposite sides are congruent. Making sense?
Yep.
Okay. All right. So let's say we have more stuff here. We know that the angles of a polygon that share a side are consecutive angles. We've talked about consecutive angles before. Okay? So if we share a side like angle B and angle C, now if you look at those, you can tell that those two angles are not congruent. They are not congruent. How do I know? Well, I know because angle B is obtuse. Angle C is acute. So they can't be the same angle measure. But they're called consecutive angles. Let's look at the broader scheme here. If I take a look and I extend out AB, and I extend out DC, and I extend out BC, it looks to me like I've got parallel lines cut by a transversal. Remember doing that first semester?
Yes.
Yeah. Do you happen to remember the name of those two angles I have marked from that same side interior? Or we also call them consecutive interior angles. Same side interior angles or consecutive interior angles. It was the same thing, different name. And do you remember what was true about those angles? They were supplementary. We learned that way back when. We're coming back to it again. Same side interior angles are supplementary. So that means if we have a parallelogram, for example here, Theorem 6-4, if we have a parallelogram, then we know that consecutive angles are going to be supplementary. So I know, and there's that whole list of all the consecutive angles, I know that angle A plus the measure of angle B is 180. B and C are supplementary. C and D are supplementary. D and A are supplementary. Okay? That is always going to be true for parallelograms. And again, that goes way back to when we talked about parallel lines cut by transversals. All right, let's see here. Let's go to our Theorem 5. Theorem 5. We could go through and do a whole lot of work here. And again, it goes back to parallel lines cut by transversals. But if I continue to work with that parallel line cut by transversals, I'm going to end up getting that in my parallelogram, my opposite angles are going to be congruent. Opposite angles are congruent in a parallelogram. And let me show you real quick. I'll try to make it real quick as far as how or why that is. So, let's extend out some sides here. I got that. We got this side. This side here. Now again, we're thinking back right now to parallel lines cut by transversals when we talked about those, okay? And I'm just going to, for the sake of argument, start by marking this angle with a single mark. Okay? So, we learned way back when that same side interior angles are supplementary. So that means this is some other angle measure, but I know that those two angles add up to 180. Right?
Yeah.
Okay. We also learned then that we have something called corresponding angles. Corresponding angles were congruent, such as this angle up here and that first angle I marked. Those two angles are corresponding angles, and they have to be congruent. Well, then, look at this. I have parallel lines, meaning this parallel line and this parallel line cut by this transversal, making alternate interior angles. Oh, that means this one must be a single marked angle as well. Okay, I have corresponding angles here. This angle here and that angle there are corresponding angles, giving me my parallel lines, again, cut by that transversal. And again, look, I have alternate interior angles here, giving me that to be congruent to the angle up here. So by doing all that, I have now shown that yes, in fact, the opposite angles in my parallelogram are always going to be congruent. If I have a parallelogram, opposite angles are congruent. Why? Because I could go way back to those previous theorems about parallel lines cut by transversals and reproduce that same statement. Questions on this theorem? No? Doing okay? All right. So let's take a moment to fill in our flow chart with this information. All right, so looking at our first example here, it says to find the indicated measure in, what does that shape again mean? Right, it's parallelogram, not quadrilateral. Parallelogram, KLMN. So, they want us to find x. Well, x shows up right down here, 2x minus 3. That's a side length, right? The side length for Kn. How are we going to find x then?
37 equals 2x minus 3.
Right, the opposite sides in our parallelogram have to be congruent. So since the opposite sides are congruent, we can then set up an equation. 2x minus 3 equals 37. And we solve. Adding 3 to both sides, we get 2x equals 40. Divide by 2. So x equals 20. Any questions on doing that? Okay, well, next they want us to find y. Next they want us to find y. How are you going to go about finding y? Opposite angles are congruent, and so we look at L. We look at L. If L is 123 degrees, that means y has to be 123 degrees. Okay. Lastly, they want us to find z. Well, how are we going to go about finding z? Consecutive to angle L. We're going to use these two angles. What do we know about the consecutive angles in a parallelogram? They are supplementary. So z plus 123 equals 180. So we subtract out 123. What do we get for z? 57. Okay, 57. There we go. Okay. Any questions here? No. All right. So let's head to the next page. On the back page here, we have another property that we want to talk about. Okay. This property says that if a quadrilateral is a parallelogram, then its diagonals bisect each other. The diagonals bisect each other. So, if we know we have a parallelogram, then if we look at the diagonals, and here you got to be very careful, the diagonals bisect each other. So the two diagonals are going to intersect. That intersection, this is another vocab word from a while ago, that intersection is then the midpoint for both diagonals. Okay? Now, is it telling me that all four of those small segments are congruent? No. It means each diagonal is being cut in half. Each diagonal is being cut in half. Looking at this example, we want to solve for x and y. Okay? We want to solve for x and y. Now, we know that we have a parallelogram, and we see that line segment LN and line segment KM are diagonals. So we know that they bisect each other. That means that this segment is congruent to this segment, and this segment is congruent to that segment. So we need to go ahead and write a couple of equations, because we know that they're going to be equal to each other, right? They bisect each other. So we know that x equals y plus 2. Right? And we know that y plus 10 equals 2x minus 8. All right. This brings up a topic from Algebra 1 called a system of equations. Okay? Otherwise known, this is called the fundamental rule of algebra, basically, is that if you have only one equation, if you have one equation, you can solve it if you have only one unknown. But if you have two unknowns in one equation, you can't solve it. Like that first equation, x equals y plus 2. I cannot tell you positively what x is going to be. I can't tell you positively what y is going to be. I could graph a line and show you all the possible combinations, but I can't tell you positively in this problem that x equals, say, 4. I can't do that. Okay? So what we need then, if we have two unknowns, we need two equations. If we have four unknowns, guess how many equations we need? 4 equations. You need an equal number of equations, different equations, as the number of variables you're looking for. Okay? And what we're going to do here is we're going to use a process called substitution. I don't know what x equals exactly, but I do know that x equals y plus 2. And so I'm going to take y plus 2, and I'm going to substitute it in for x in the second equation. And so I get y plus 10 equals 2 times y plus 2 minus 8. Now notice I have one equation and all it has in it are y's. So now I can solve that one equation for y. I need to distribute 2 first. So y plus 10 equals 2y plus 4 minus 8. And I want to start combining like terms here. So I have y plus 10 equals 2y minus 4. I want to get my y's on one side together, so I'm going to subtract y from both sides. I want to get my numbers on the same side together, so I'm going to add 4 to both sides. And I get 14 equals y. Well, that's good. I found y, but now I need to find x. So I take that value of y I just found, and I plug it in for y up in that equation that says x equals 14 plus 2. That's great. We did most of the work. Problem is, did we actually solve for the lengths of our diagonals they asked for? No. So we got to plug stuff back in and solve. The nice thing is we know that if x is 16, that means y plus 2 is 16. We don't have to do a ton of work there, so I know already that ln equals 32. Now I need to do a little bit of work for the other diagonals. If y is 14, that means I have 14 plus 10, so this must be 24. That means the other part must be 24. So that tells me that km must equal 48. Questions? No? Real quick here, I want to talk about 6, 7. I just want to make sure you see it before you get into your homework. We'll talk about it more tomorrow. Or on Monday, I mean. But all they're saying here is that if I have a bunch of parallel lines cut by transversals, if I know that those parallel lines are forming congruent sides on one side like that, you guys aren't looking up here. You see that, how they're congruent on one side? Then this is just saying that that means they must be congruent on the other side as well. That's all they're saying in this diagram. If it makes congruent segments on one side of the parallel lines, then the other side are also going to be congruent segments. Okay?